In this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable, which doesn't mean that you can't use it to check your answer. Figure 3 shows a sketch of part of a curve with the equation given here. The region R shaded in figure 3 is bounded by the curve and the x-axis. Find the exact area of R, writing your answer in the form a root 2 plus b, where a and b are constants to be found. Now, we really need to know these values here, but that's when the top is going to be 0. And we can see the values that make the top 0 are 2 and 4. So those are the limits. So we have the integral from 2 to 4 of x minus 2, x minus 4 over 4 root x dx. Now, that's going to give us the value that's the negative of the area. So we could put a minus in front of this and just go down with it, but we'll just use it at the end, I think. Now, there are various ways of doing this integration, but I think the most straightforward way is just to simplify the algebra. Let's bring the 4 in front, and we have integral from 2 to 4 of expanding the top. We get x squared minus 6x plus 8, and the bottom is x to the half. And then we can split the fraction. So integral 2 to 4. So we've got x squared over x to the half. Take away 6x over x to the half plus 8 over x to the half dx. So that is a quarter of the integral from 2 to 4 of x to the 3 over 2. Take away 6x to the half plus 8x to the negative a half dx. And so that is a quarter of. So that would become x to the 5 over 2 over 5 over 2, which ends up being 2x to the 5 over 2 over 5. And then we'll have 6x to the 3 over 2 over 3 over 2, which ends up being 4x to the 3 over 2. These are the sort of things you can use your calculator to simplify anyway. And then finally, we'd have 8x to the half divided by a half. 8 divided by a half is 16. So that's 16x to the half. And that's to be evaluated from 2 to 4. So I'm just going to rewrite this a little bit. X to the 5 over 2. My favourite way of writing that, since that is x squared times x to the half, is x squared root x. And I prefer it to be back in radical form before I substitute in. And then we've got 4x root x. And then we have 16 root x. And that's going from 2 to 4. So that will be a quarter. And substituting the 4 in there, this will be 16 times 2 times 2, 64 over 5. And then we would have 16 times 2, which is 32. And that one's going to be plus 32. And then we'll have take away. Putting 2 in there is going to give us 8 root 2 on 5. Take away 8 root 2 plus 16 root 2. And those are going to go. So that is going to be 1/4 of 64 on 5. Take away 8 root 2 on 5 plus 8 root 2. And so that is going to be 16 on 5. Take away 2 root 2 on 5. I'm just multiplying the quarter in this time. Plus 2 root 2. and that is 16 over 5, and that is going to be a 2 root 2 on 5 plus 10 root 2 on 5, which is 12 root 2 on 5. The area then is just going to be the negative of that, as we discussed. So it's 12 root 2 on 5, take away 16 over 5.